Room 21 Rockstar. So we're starting off today classifying some quadrilaterals. Here on the screen you are going to see that famous dichotomous key that we continuously are coming back to time after time again, the quadrilateral dichotomous key, because it's really the best way for us to use all of that rich vocabulary to identify quadrilaterals. So let's get right to it. So pretend that this big quadrilateral key is on the floor and here are my feet, they're walking down it. Remember, I start at the top with the quadrilateral and all of our figures, four-sided figures, are here. As I get down to the very bottom of the dichotomous key, I get more specific. And you remember, all of these can go right up in there. That's what we put into our math notebook. So today I want to point your attention to this swimming pool right here. Okay. The big thing about this swimming pool is I want to be able to identify what type of quadrilateral this is. So I have already identified that yes, indeed, this is a quadrilateral. Okay, so that's, you know, first and foremost, it is a four-sided figure. Okay, so I know it's a quadrilateral. Now, we can get more specific than that, though. I know it's not a trapezium because a trapezium has 0 sets of parallel sides. This obviously has 2 sets of parallel sides. It's not a trapezoid because a trapezoid only has 1 set of parallel sides. Therefore, it does not go there either. Okay, and now I'm going to go down this route here. So I know I have a quadrilateral. Then I'm going to travel down. Here we have the parallelogram. What's specific about a parallelogram, guys? Yeah, it has 2 sets of parallel sides. Here's a set, and here's a set right here. And if you need further clarification, I can draw my markings here to show you that these sides are parallel. Okay, is this a parallelogram? Does it have 2 sets of parallel sides? Yes. So now I'm going to travel further down the dichotomous key. Now I know that I have this swimming pool is a quadrilateral. It is a parallelogram. Now I'm trying to travel further down the dichotomous key to see if I have anything even more specific. Okay, so next down I see that I have my rectangle. Now the specific thing about a rectangle is that it has 4 right angles, and here are my 4 right angles right there. Does the swimming pool have 4 right angles? Yes, indeed. So I also have a rectangle. So this is a quadrilateral, the swimming pool. It is a parallelogram, and it is a rectangle. Remember, the rectangle is the most specific form of this quadrilateral. So I have a quadrilateral, parallelogram, rectangle. Now let's see if I have even further down a square. What's the most specific thing about a square, guys? Yeah, it has 4 congruent sides, shown with those markings, or those hash marks there, right there. Does this swimming pool have 4 congruent sides, would be the question. 4 congruent sides? No. So what I have in front of me is a rectangle. Yes, it's a quadrilateral. Yes, it's a parallelogram, but mostly it is a rectangle. And move on to another one, because I thought this building was so cool because there are so many different figures here. The first thing that I want us to look at, though, although there are tons of different figures, would be this yellow outline right here. Does everyone see that? So we're going to use our dichotomous key to figure out the most specific name for this quadrilateral. So once again, I'm going to kind of speed through it a little faster this time, guys. I know that I have a quadrilateral. Okay. Are there 0 sets of parallel sides? No, because this side is parallel to this side. Those 2 opposite ends are parallel, therefore I do not have a trapezium. Now, do I have a trapezoid? 1 set of parallel sides, the others are not. Because if I ran these 2 sides on forever and ever, they would definitely meet right there at this point. So I do have a trapezoid. Now, do I have 2 sets of parallel sides? No. So this is called a trapezoid in its finest. Now, there are a ton of other figures here, guys, that you could actually practice identifying. Let me just erase this really quickly to kind of get that idea away from you, but there are a ton of different things there that you could check out, including the windows, if you notice there. Okay, you could also practice identifying this vent up here, or this strip of you know, siding or something there as well. You could do this figure if we cut this figure in half. Okay, a ton of different ways to identify figures. Practice doing a few of those. I'm going to take us on to one. So our final little practice with quadrilaterals, guys, is really important because here on this slide I've taken away the dichotomous key because, like I said, eventually I want you to start moving away from that. Now, is it okay to look back at that dichotomous key? Dichotomous key, yes, guys, it is okay to look back at that. But this time, these figures have been identified with different types of markings. You know, our side lengths are identified by numbers. You know, we don't know the unit, but we can assume that they mean inches, possibly, or centimeters. So these numbers identify the side lengths of the figures, okay? And some of the angle measures have been identified. So really quickly, I want you, in your mind, using that dichotomous key if you need to think about what each of these figures are. What do you think about this one to begin with? What do we think, guys? What is that figure? Okay, we have four-sided figure. Obviously, these sides are parallel. We have four right angles, and we have four sides of congruent measure. Yes, this is a square. Very good. Now, if I look at this figure, not much different between these two figures, but something very important is different. So we have the parallel sides. Opposite sides are parallel. We have two sides that are 3 and two sides that are 2, meaning we do not have congruent sides, meaning that this is a rectangle. Very good. This figure right here, I have only one set of parallel sides. These sides are not parallel. Eventually they would travel together and meet. Okay, so I know that I only have one set of parallel sides. A figure with one set of parallel sides is automatically a trapezoid. And finally, this figure down here, well, I have I have two sets of parallel sides, but they're different lengths. I do not have right angles, so this is a parallelogram.